Now I'm going to show you this image IO module that I've been talking about. Another word, by the way, you'll hear people, instead of just module, sometimes people will say library, because in many other languages, these modules are called libraries. So first, let me actually show you what this file looks like. So you'll be given a file that looks exactly like this image io.py. Now up here, it says from PIL import image. This is that module that I was telling you about that's quite complicated. It can do lots of different things for reading in and writing to images. All you will have to do is use these two functions that are provided in this module. The read file function, which takes in a file path and gives you back an image, like a list, a two-dimensional grid of pixels where each pixel is 3 numbers. And then this write to file function, which given some file name, including the path, and this image matrix, it will write this file to storage. We'll talk a little bit more about what these are, what all this here is in a minute. But using this image.io.py module, how do we use it? So just like any other module, as long as you have this file here in the same directory as your code, at the top of your code, you'll just have a line that says import image_io. And now, from then on, you can use this image equals image.io.read file. And I can come back here and show you. So we have image.io.py in the same directory here. So I will first import image.io. And now I will do, my image is going to be image.io.read file. And the file that I'm going to read here is image.png. And so if I go ahead and print out this image, on 3 main.py. Whoops. So actually, our image is called image.png, but it is in this input folder. So we have to provide the path as well, relative to where our file is. So our main.py is here, and our image is input/image.png. So here we have, here's the given image that I have. It's just 3 pixels across, 4 pixels tall. And this is this two-dimensional grid where each item is itself a list of 3 values. This is what our image is represented by. Now I wanted to show something before I talk about writing. You might ask, well, hey, why can't we just use the, with open as f, the same thing that we did for text files? Why can't we do that? That seemed to work. So if I comment this out for a second, with open poem.txt as f, print f.lines. This seemed to work when we did print f.lines. Read lines. So if I come over here and I run our code, of course I forgot the input again. It should be input/poem.txt. We see exactly this. This poem file says 2 roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. That indeed prints out our text. So what if we tried doing that with our image file, with open image.png as f? Well, and of course, forget to put input/image.png. This will give us an error because open as f, reading lines from a file, you have to assume that the file is made up of characters, just letters, not just arbitrary bits and bytes. And so here, our file actually isn't made up of letters, it's made up of these pixels. And the way that a PNG file stores pixels is actually different than just text, which is what I was mentioning before. In fact, I'll show you here. This isn't something that you need to know for this class, but there's this command that you can use called od -c-b. This will show us. So first I'll do it for input/poem.txt. This will show us exactly what's stored in memory. So from the beginning of the file, our file starts at 00000 in memory. You have 2 space roads space diverged space, and so on and so forth. So the top row for each of these is like the characters, and these are the actual numbers, the actual bits, bytes that are stored in memory that represent these characters. And so you can see these numbers, these bytes, are decoded into letters. T, W, O is 157. In fact, you might kind of be pained to see this. See that these numbers are slightly different than the numbers that we used in the ciphertext, but it's the same idea here. Like A right here is 141, E is 145, D is 144, B is 142. So there's some mapping from this number that is actually a byte to the character. But now if I were to do the same thing to peek inside what letters and what characters are stored inside of our image, we can see that, okay, it starts off with a couple of regular letters like P, N, G, but after that, it's kind of nonsense. 120, 000, 0 IDAT X 234 005 301. Like some of this stuff doesn't really, this doesn't look like text. And so that's why the regular open reading lines from the file won't work. Which is why we need a different library to handle this different way that memory is stored. If you want to play with this on your computer, you can peek into any file you want and see how it's actually, like what's inside of the file, like what actual bits and bytes, what ones and zeros are set inside the file by using this command, od space -c space -b space the name of the file. And here we have the first 20 bytes in our file. The next 20 bytes, you can see this becomes 20, 40, 60, so on and so forth. Okay, going back though, we now know how to read in a file. If I run our code again, we get back this grid of pixels.